Kim 107 students, welcome back. You may have noticed at the end of my last video, the audio and the video got a little out of sync. I am aware of this problem, and unfortunately, it's going to happen in many of my videos. I have spent hours with tech support trying to figure out why my computer does this, and no one has a clue. We've tried everything to fix this issue. But my audio and video sometimes are out of sync, and I record these videos 3 or 4 times and just have to take the best one. So I'm doing the best I can, and I'm really sorry that sometimes the audio and the video are going to be out of sync, but again, I'm doing the best I can. So let's continue on with chapter 1. This is now our 4th video. We are up to physical changes. These are changes in the state of matter, meaning changes from solid to liquid to gas or back, gas to liquid to solid. So what's the name for solid to liquid? So when ice turns into water, what's that called? Melting. Yeah, melting. What about liquid to gas? So water to steam. Yeah, boiling. What about gas back to liquid? This is a hard one. It happens in your shower on the mirror. Yeah, condensation. What is liquid back to solid? So water to ice. Freezing, good job. Now you may not know it, but some chemicals skip the liquid state. They go straight from solid to gas. Anyone know what that's called? It's sublimation. And then gas back to solid. This is the hardest one. It's called deposition. So there's the words there. Now, I want to talk a little bit more about boiling. Another word for boiling is vaporizing. That's just kind of a fancy word. Boiling and vaporizing both mean liquid to gas when we add heat to something. So like when you boil something, it boils throughout the whole liquid. Like on your stove, you have little bubbles in water when you boil water. Evaporating is also liquid to gas, but it only occurs at the surface of the water and you're not heating it up. It just occurs naturally, like your dog's water bowl. After days and days and days, the water will evaporate if it just sits there. So it's not at the boiling point. Boiling is at the boiling point. It's hot. Evaporating just occurs naturally to liquids that just sit there. So two very different things, boiling and evaporating, even though they both refer to liquid to gas state. All right. So physical changes are changes that keep the chemical composition the same. So the molecules stay the same with the same formula. So in other words, if I have H2O liquid, water, and I boil it, I'll make H2O gas. See, the only thing that changed is liquid to gas. H2O stayed the same formula. So physical changes are changes in state. The only thing that change is S for solid to L for liquid to G for gas or backwards. So again, boiling water just makes water in the gas state, which we call steam. The H2O stays the same. So what happens if I melt NH3? I get NH3. What happens if I sublime CO2? I get CO2. See, the formula stays the same for physical changes. Here's a graphic from your book just showing you solid, liquid, gas, and the name of the 6 physical changes: melting, freezing, boiling, condensing, sublimation, deposition. Remember these 6 changes. You will see this again. Chemical changes. Chemical changes change the chemical composition. The molecule has atoms breaking apart, rearranging, so the formula changes. So if we have H2O undergoing a chemical change, we don't get H2O. Okay, it's something different. So chemical reactions and chemical changes are the same thing, and they change the molecule. Whatever you start with is destroyed, and a new substance with different formula and different properties is formed. Like burning gasoline. We put gasoline in our car, and it goes through the engine and burns and does its thing, and then it comes back out as gases at the end. Is it gasoline coming out of your tailpipe? No. If it were gasoline coming out of your tailpipe, we'd stick a little hose and reroute it back to the gas tank. And then it would just continually make a loop, and that would be really nice. You'd never have to fill up your car again. But that's not reality. When we burn gasoline in our gasoline-powered cars, what comes out the tailpipe is not gasoline. Thus, burning gasoline is a chemical change, a chemical reaction. Here's a fun chemical reaction. We can take sodium metal, pictured there, the gray pieces of solid, and react it with chlorine gas. That's the yellow vapor in the second picture. So we have a solid metal sodium. The symbol for sodium is Na. We have chlorine gas. The symbol for chlorine is Cl. And you combine them together and you make salt, NaCl. Salt is a totally different chemical with a different formula and different properties than the reactants. Sodium metal is explosive. It'll explode and catch fire if you have it interact with water or even humidity in the air. So exploding solid, chlorine gas is toxic. So toxic gas, and they produce salt. What do we do with salt? We eat it. So exploding metal plus toxic gas makes salt that we eat. So again, the point is a chemical change changes the chemical. Salt is something we eat, and it's necessary for life, but it has little characteristics in common with an exploding metal or a toxic gas. So chemical changes completely change the chemical, and they have different properties than what you started with. So here are some changes, and I want you to decide if they're physical or chemical. Number 1, NH3 gas becoming NH3 liquid. It's NH3 on both sides. So the only thing that changed was gas to liquid. So is that physical or chemical? Physical, because we only changed the state of matter, gas to liquid. Number 2, we have some NH3 gases becoming N2 gas plus 3H2 gas. So NH3 on one side, N2 and H2 on the other side. Is that the same on both sides? No, different means chemical change. Good job. Number 3, H2O2 liquid becoming H2 gas separated from the O2 gas. So H2O2 on one side, all together in one molecule. And on the other side, we have H2 separated from O2. So is that the same? No, it's different. Different means chemical change. Good job. Number 4, H2O2 liquid becoming H2O2 solid. We have H2O2 on both sides. The only thing that changed was liquid to solid. So that is physical change. Good job. And the last one, number 5, C6H6 liquid becoming C6H6 gas. I hope you said physical. Physical is correct. The only thing that changed was liquid to gas. So physical, chemical, chemical, physical, physical. All right, and that's where we're going to stop this video. We'll pick up next time. Bye, 107 students.